हाय एवरीबॉडी, वेलकम बैक। तो शुरू करते हैं आज अपना फिर से टेलीकॉम सीरीज़ का एक नया पार्ट। सिलेबस इज एटीएम ऑन सोनेट, नेटवर्क कॉन्फ़िगरेशन, एसटीएम फ्रेम स्ट्रक्चर एंड ओवरहेड ऑन एसटीएम. So we all know the SONET offers flexibility of concatenation STS1 to provide necessary bandwidth for wideband services like ATM. SONET allows concatenation 3 STS1 to 155.52 Mbps, which I already explained in previous videos how we are forming 155.52 Mbps. Beyond STS3, we have concatenation in multiple of STS3C. Virtual turbidity can be concatenated up to VT6. ATM is asynchronous transport module that we are using on SONET. So basically we are using ATM on SONET. So we have OC3C has same bitrate as OC3 but interpreted as one channel instead of three multiple channels, which stands for nothing but concatenation. Previous video we have seen that architecture of the SONET SDH, and we have also seen the path layer of this SDH structure. So we have a PTE, that is primary telecom equipment. Then we have REG. REG is a regenerator section. Then we have ADM, as already explained. Add drop multiplexer is there. Whatever we have at TX side, same we will having on RX side. So let's have a review on how STM frame look like. It has 125 microsecond frame, 270 into 9 rows, 270 into 9, 2430 bytes are there, and capacity is 155.52 Mbps. We have SOH, that is 9 to 9 rows into column. Payload includes POH, path overhead, floats in STM frame, and pointer byte shows that start of floating payload. So we can see this, the small chunk of the frame structure here in this diagram. Let's have a look on this, the bytes, as I committed in previous video that I will explain each and every byte, the functionality of RSH and MSH, that is regeneration section overhead and multi-section overhead. So A1 and A2 stands for frame alignment, which shows the beginning of any STM frame. Basically value of A1 is F6 and A2 is 28 in hexa. A1 stands for the byte errors, which checks the parity for error check. 0 is path check, which tells the path trace around the SGH network. One is order wire, that is used between the speech communication between regeneration sector. F1 is used for the speech and data transmission for maintenance purpose. From D1 to D2 to D3, each having capacity of 64 kbps, into 3 which is 192 kbps, that is used for data communication. B2 for MSS section, which is used for the bit error and monitoring. And K1 K2 bytes are used for multiple section protection and switching. Whenever there is a K1 and K2 bytes are 0 and 1, and when it changes, the other sides get to know that there is a fault or fiber break is there, so its value changes. If it is 1, it goes to 0. If it is 0, it goes to 1. D4 to D12, again data communication channel, each having 64, which means it is around 512 kbps. This one is used for the synchronization. Z1 Z2 are spare bytes. M1 is used for the MSS section for the remote error byte for the B2 interleaving system. So these are the various bytes which are very important for the SGS chronology. You can deep dive and research on these individual functionality of the bytes, which is very important for telecom perspective. And I have seen that most of the interviews you are going to ask questions from these bytes only.